Today we're going to find real zeros of polynomial functions. We're going to do this through two different methods. The first is long division, and the second is going to be through synthetic division, also looking at what's called the remainder theorem. So let's begin with long division. The problem I have is 6x to the third minus 19x squared plus 16x minus 4. I'm going to divide this by x minus 2 using long division. And I want to use the result to factor the polynomial completely. Okay, so let's first set this problem up. Just like most long division, I'm going to set this up like this. My answer is actually going to be up on top here. And on the inside, I will have the polynomial that I am dividing. 6x to the third minus 19x squared plus 16x minus 4. What's worth noting is if I'm missing a term, let's say that I didn't have this minus 19x squared here, and I went from 6x to the third straight to plus 16x. I would need to make sure to use a placeholder. So I would need to do plus 0x squared here if that wasn't actually there. However, it is here, so I'm just going to write it. Same thing with what I'm dividing by. So I've got x minus 2. I'll just put that over here. But let's say I was dividing by x squared plus 4. I would be missing the x term, and I would want to make sure to do x squared plus 0x and then plus 4 on the outside if that's what I was dividing by. All right, this is my setup. Then after I set this problem up, I'm going to follow 4 steps repeatedly until I get to the very end. Let's begin. Step 1. Divide the first term on the inside by the first term on the outside. So 6x to the third, I'm going to divide this by x. This is going to give me 6x squared. And I'm not going to put that right up here at the front. I'm going to keep nice and straight columns. This is my x to the third column. This is my x squared column. This is my x column. And this column will be for my constants. So 6x to the third divided by x gives me 6x squared, which I will put up there. Then step 2, you're going to take the result and you're going to multiply to all of the terms on the outside. So 6x squared times x, this is going to give me 6x to the third. And 6x squared times negative 2 is going to give me negative 12x squared. Step 3, we are going to subtract. Now you'll notice that this 6x to the third and this 6x to the third is exactly the same. It's identical. And it has to be because these are going to subtract out. And that's going to leave negative 19x squared minus negative 12x squared is going to be negative 7x squared. Next, I've got one term here. I'm dividing by 2 terms. I want to bring down the 16x here. Then I'm going to repeat back to this first step. Take the first term on the inside, divide by the first term on the outside. Well, the first term on the inside now is negative 7x squared. I'm going to divide this by x, and that'll give me negative 7x. Then I take this, whatever I just got, and I'm going to multiply to all the terms on the outside. So negative 7x times x, this is going to give me negative 7x squared. Negative 7x times negative 2, that's going to give me plus 14x. And then I'm going to subtract. So this is step 3. What you'll notice again is these are exactly the same. Those need to be, so they'll subtract out. What are you left with? 16x minus 14x is 2x. And bring down or drop down the next term. So dropping this down. And the whole process starts again. So step 1, first term on the inside, divide by first term on the outside. 2x divided by x, that's going to give me a 2. I'm going to take this 2 and I'm going to multiply to all the terms on the outside. 2 times x gives me 2x. And 2 times negative 2 will give me negative 4. Subtract. And we'll see here that both of these terms, 2x minus 2x goes to 0, negative 4 minus negative 4, that's going to go to 0. My remainder is 0, which is good because it's asking me to factor this completely. So far, I've got the following. X minus 2 times 6x squared minus 7x plus 2. But I know I can factor this further. So I'm going to do that over on the right side here. Let's rewrite this. 6x squared minus 7x plus 2. Factoring this, I can say a equals 6, b equals negative 7, and c equals 2. So a equals 6 and c equals 2 is what I'm going to start with. And I'm going to find all the things that multiply to get to a equals 6. Well, that's 1 times 6 and 2 times 3. And then for c, I'm going to say all the things that multiply to get to c, 1 times 2, and the reverse, 2 times 1. But I know that b is negative 7. Which means that if these were all of my factors, if I multiplied positives here with positives over here, I would never get to a negative result. So I must also include negative 1 times negative 2 and negative 2 times negative 1. And because I know I want something that's negative, I'm not even going to include these as options. Now it's a matter of kind of guessing and checking. So let's give it a shot. If I do 2 and 3, that means that this will be 2x here and 3x here. Now I can save a little bit of time instead of trying this out and then foiling each of these binomials or doing a box method for each of these binomials. I can just multiply the outsides and the insides to see if I can match up to this negative 7x. What I mean by that is, let's just look at the first option here and the first option here. If I multiply the outsides, 1 times negative 2 would give me negative 2. 6 times negative 1, so these are the insides, 6 times negative 1 would give me negative 6. And then if I add those together, negative 2 plus negative 6 is negative 8, which is not the same as this negative 7, so I know that's not correct. But let's try something with 2 and 3, since I've already written 2x here and 3x here. 2, 3, and let's try the bottom one, since we did the top here and the top here. Let's try the bottom and the bottom here. So that the outside would be 2 and negative 1. 2 times negative 1 will give me negative 2. Okay, and then 3 times negative 2 is going to be negative 6. Negative 2 and negative 6, well, that gives me negative 8 again. All right, well, let's try 2, 3, and negative 1, negative 2. Outside would be 2 times negative 2 gives me negative 4, and then 3 times negative 1 would give me negative 3. Negative 4 plus negative 3, that's negative 7. So let's see, that was 2, 3, and negative 1, negative 2. So 2x will go on the left side, 3x will go on the right side, and then negative 1 and negative 2 will go to the left and right, respectively. So this is the same as saying x minus 2 times 2x minus 1 times 3x minus 2. And now this polynomial is factored completely. Let's do another one. Let's try x to the third minus 4x squared minus 17x plus 6, and I'll divide this by x minus 3 using long division. Note here, it does not say factor completely, so once I find my answer, we're done. All right, let's set this up. X to the third minus 4x squared minus 17x plus 6 dividing by x minus 3. All right, that's my setup. Then I follow 4 steps and I repeat these 4 steps over and over until I come to my solution. X to the third divided by x, the first term on the inside divided by first term on the outside. That's going to give me x squared. I'm going to put that in my x squared column. All right, then take this and multiply to all the terms on the outside. So x squared times x, that's going to give me x to the third. X squared times negative 3 is negative 3x squared. And then step 3, I'm going to subtract. These will always subtract out because they're the same. And then negative 4x squared minus negative 3x squared, that's going to give me a single, so negative x squared. I've got 2 terms out here. I've only got 1 term here, so I'm going to bring down the next term, negative 17x, and repeat those 4 steps. Step 1, first term on the inside divided by first term on the outside. Negative x squared divided by x, that'll give me negative x. Step 2, take whatever I just got, multiply to all the terms on the outside. Negative x times x is going to be negative x squared. Negative x times negative 3 is going to make a positive 3x. And then step 3, let's subtract. These are exactly the same. They should be. They're going to subtract out. And I've got negative 17x minus 3x. This is going to give me negative 20x. And bring down the next term. Okay, and let's repeat all 4 steps again. First step, first term on the inside divided by first term on the outside. Negative 20x divided by x, that is going to be negative 20. Take this, multiply to all the terms on the outside. So negative 20 times x, that'll be negative 20x. Negative 20 times negative 3, that's going to make positive 60, so plus 60 here. Step 3, we're going to subtract. Six minus 60, that's going to be negative 54. So negative 54 is actually my remainder right here. So how I write this as my answer is I write whatever I found up here, x squared minus x minus 20, x squared minus x minus 20, and to write my remainder, I can say plus, and then negative 54 over, I'm dividing by x minus 3. So that's how we use long division. We're going to switch to synthetic division next. Now, synthetic division is a little less work, but it's more restricting. For long division, you can do this with practically any polynomials that are given to you. You can divide a polynomial that is, 15 different terms by one that is 4 or 5 terms. However, with synthetic division, our restriction is that we're always dividing by something that x minus a, x plus a, something that looks like that. So here's how to set this up. With synthetic division, I care more about the coefficients on each of these terms when I start out. I'll begin by creating kind of that same half box, but this time it'll be upside down. Then I look at my coefficients. And I'm going to start with x to the fourth. I've got 1x to the fourth. So I'm going to write a 1 right here. Next, x to the third. I don't have any x to the thirds. So that means that I have to create a placeholder. So I'm going to say 0x to the thirds are right here. Then for x squared, I've got negative 10x squared. So minus 10. So negative 10 for my x squareds. For x's, I've got negative 2. And then finally, at the very end, my constant is a 4. Now I'm dividing by x plus 3. What I'm going to have you do is over to the right, we're going to put x plus 3, and we're going to set this equal to 0. And solve this. Subtract 3, x equals negative 3. This negative 3 is what's going to go on the outside. And the last thing I do to set this up is I always bring down that first number. So I'm going to bring down this 1. All right, now that I'm set up, I can actually do synthetic division, which ironically doesn't use a whole lot of division. The two steps that I have are to multiply diagonally, and then the second step is to add straight down. So negative 3 times 1 is going to make negative 3. And then I add straight down. 0 plus negative 3, well, that's going to make negative 3. Multiply diagonally. Take this, multiply over here. Negative 3 times negative 3 is going to make positive 9. Add straight down. Negative 10 plus 9 is negative 1. Multiply diagonally. Negative 3 times this negative 1 is going to make positive 3. Add straight down. Negative 2 plus 3, that's going to make positive 1. Multiply diagonally, 1 times this negative 3, that'll be negative 3. And finally, add straight down 4 plus negative 3, that's going to make a positive 1. Now this last number, I'm going to put a little bit of I'm going to put a little circle around it in red. Because this is actually my remainder. So let's find the answer. What was the highest power that we started with? This was x to the fourth. What I'm going to do is I'm going to take that power and I'm going to drop it down 1. So dropping this down 1 would be x to the third. Well, my answer is down here. This is 1x to the third, or just x to the third, minus 3x squared, just keep bringing it down a power, minus x plus 1, and then my remainder is plus 1 over, I'm actually dividing by x plus 3, so don't confuse that with your negative 3 over here. So this is your solution and how you use synthetic division. Now let's do another one like that. 3x to the fourth minus 6x to the third plus 4x squared plus 7x plus 1. And I'm going to divide this by x minus 4 using synthetic division. All right, let's set this up. Do an upside down box, if you will. And on the inside, I'm going to put these coefficients. First, am I missing any terms? X to the fourth, then third, second, first, and a constant. So I'm not missing anything. I don't need any placeholders like I did this 0x to the third, because in the first one here, I didn't have an x to the third term. I need to put a 0. That's not the case for this one. So So this will be 3 x to the fourth, then negative 6 for x to the third, 4 for x squared, 7 for x, and then 1 for my constant. I'm dividing by x minus 4. So over to the right, I'm going to say x minus 4 equals 0. And we are going to solve for x, adding 4 to both sides. X equals positive 4. This positive 4 is what's going to go over here. And then lastly, I drop down my first term. Okay, so now I'm set up. Let's do this. 2 steps. Multiply diagonally, add straight down. So multiplying diagonally, this will give me 12. Adding straight down, negative 6 plus 12 will give me positive 6. Multiply diagonally, 4 times 6. 4 times 6 is going to be 24. That's going to go up here. Adding straight down, 4 plus 24 is 28. Now it looks like the numbers are going to get a little bit large here, but that's okay. 4 times 28, multiplying diagonally, that's going to be 112. And then adding straight down, 7 plus 112 is 119. Multiplying diagonally, 4 times 119, this is going to be 476. And finally, adding straight down, 1 plus 476, well, that's 477. And because it's the last number here, I'm going to put a little circle or an oval around it, because that's my remainder. My solution is, well, let's see, my highest power was x to the fourth, so I'm going to drop that down 1, and that makes this 3x to the third, plus, keep dropping it down 1, 6x squared, plus 28x, plus 119, and a remainder of, let's see, plus 477 over, I'm actually dividing by x minus 4. Don't confuse that with your positive 4 over here. Now there's something else that we can actually use synthetic division for. You'll notice that I put a circle around my remainder in both of these cases. That wasn't just to make sure that I recognize that that's my remainder and write it as, in this case, 1 over x plus 3, or in this case, 477 over x minus 4. It was also because I want to talk about what's called the remainder theorem for a little bit. And that says that if a polynomial, f of x, is divided by x minus k, then the remainder is r, here's my remainder, that is the same as f of k. Or in other words, do you remember in previous classes when you were asked to evaluate some function, evaluate some polynomial? Let's try that here. Let's say I want to evaluate x to the fourth minus 10x squared minus 2x plus 4. I want to evaluate that for, since I've got x equals negative 3, I'm going to evaluate that for negative 3. Okay, let's do that over here. That would be like doing this. So x equals negative 3, I'll write over here now. Negative 3 to the fourth power minus 10 times negative 3 squared minus 2 times negative 3, then plus 4 at the end. Okay, so then this is the same as saying negative 3 to the fourth power. That's negative 3 times negative 3 times negative 3 times negative 3. That's going to be positive 81. Minus 10 times negative 3 squared. Negative 3 times negative 3 is going to make 9. Minus 2 times negative 3 plus 4. So this is 81 minus 10 times 9 is 90. Minus 2 times negative 3 is negative 6. I'm actually doing subtracting a negative here, so I can say that's like adding a positive. And then plus 4. And finally, 81 minus 90, that's going to be negative 9. And then I'm going to now add 6. That's going to be negative 3. And then I'm going to add 4. This is equal to exactly 1. Which is the exact same as the remainder here. When you're asked to evaluate for a very long function, let's say it's more than just the 4 terms that I've got here, 1, 2, 3, 4. Let's say that I'm asking you to evaluate a function that is 10 terms, 20 terms. If you're allowed to use synthetic division, say x equals negative 3, and do your synthetic division, this is a lot faster than doing a whole lot of different steps to evaluate your function. And you're going to do this until you get the remainder, in this case 1, and that's going to show that it's the same as what you would get if you were to evaluate that function for x equals negative 3. I now know that this function, x to the fourth minus 10x squared minus 2x plus 4, has the point negative 3, 1 on it. I can graph that point now and confidently say, this point is on the graph of this function. I can also do that down here. So if I were to use synthetic division for 4, for this function, 3x to the fourth minus 6x to the third plus 4x squared plus 7x plus 1, I do all this and I get a remainder of 477. This tells me that this function has a point at x equals 4, y equals 477. This is a powerful tool, and it can oftentimes save a lot of time and effort when you're looking to evaluate long polynomials. Hopefully this gives you a good idea of how to use the long division, the synthetic division, as well as a look into the remainder theorem and what ways that's used as well.